Hello viewers, in our previous lecture on increasing and decreasing functions, we have discussed about the conditions when a function is said to be increasing or decreasing. Let us revise what we have discussed in our previous lecture. So if y equal to fx be a function which is defined on an interval I, the interval is closed interval a comma b, this is the subset of its domain, then this function y is said to be increasing function, if the derivative of f is greater than 0 for all x belonging to this interval, clear, a comma b, and this function is said to be decreasing if f prime of x is less than 0 for all x belonging to a comma b, and this function is said to be a constant function if f prime of x is equal to 0 or the derivative of f is 0 for all x belonging to a comma b. So viewers, in our previous lecture we have discussed these things. Now let us apply this concept in solving some problems. We have also solved some problems in our previous lecture. Now let us continue the same in this lecture also, clear? So we have here the first question, that is, find the intervals in which the function y equal to fx equal to x square e raised to minus x is increasing or decreasing. So here we have fx is equal to x square e raised to minus x. Now let us differentiate it. So we have x square times minus e raised to x plus e raised to minus x multiplied 2x. Here we have applied the product rule. Now f prime of x is equal to, take x e raised to minus x as common, so we have minus x plus 2, and this can be written as x e raised to minus x 2 minus x, clear? So here's this is our first derivative of f. Now this function fx is said to be increasing if the derivative of f is greater than 0, clear? If it is greater than 0. Now it means x e raised to minus x 2 minus x is greater than 0, clear? So this can be written as x divided by e raised to x 2 minus x is greater than 0, or we can have x times of 2 minus x greater than 0, because e raised to x is not equal to 0, clear? Now multiplying both sides by negative sign, we have this inequality as this. So this can be written as x minus 0, x minus 2 less than 0, clear? Now here's here we can find the values of x satisfying this inequality. So here we'll take two cases. Case 1 is the product of x minus 0 times x minus 2 is less than 0. So this will happen if one of the product is positive and other is negative. So let x is greater than 0 and x minus 2 is less than 0. So this inequality gives us x less than 2. Now if we plot it, this is 0, this is 2, and x greater than 0 implies this region. Here we have minus infinity, here we have plus infinity. Clear? And x less than 2 implies this region. Clear? And both these points are not included. Clear? Now case 2. Now case 2 is if x is less than 0 and x minus 2 is greater than 0. So here we have x is greater than 2 if we solve this inequality. So let us plot or shade the solution region here, and we see that this is 0, this is 2, and x less than 0 is this region and x is greater than 2 is this region. Clear? Now from these two cases, viewers, we see that the common region which satisfies this inequality is this region. Clear? So therefore this function fx is increasing if x belongs to this interval 0, 2. Clear? So here's our answer is, or our solution is when x belongs to 0, 2. So this function is increasing. Clear? Now let us find the intervals in which this function is decreasing. Clear? So for decreasing we have the derivative less than 0. Clear? So here's for fx to be decreasing, the derivative must be less than 0. And what is our derivative? The value of the f dash x is x e raised to minus x, and here we have 2 minus x is less than 0. Clear? Now again we'll have the same explanation here, and e raised to x is not equal to 0, so we omit this. So we have x 2 times of x multiplied 2 minus x is less than 0, and we have x minus 0, or we can multiply both sides by negative sign or minus 1. So we have x and x minus 2 greater than 0. This can be written as x minus 0, x minus 2 greater than 0. Now viewers, again we will take two cases. Clear? Case 1 and case 2. Here we have 0 and 2. Here also we have 0 and 2. This is minus infinity, this is plus infinity, this is minus infinity, and this is plus infinity. So here's this inequality will be satisfied if one of the if both the products are less than 0 or both the products are greater than 0. Clear? So here we have x greater than 0 and x minus 2 greater than 0. So if we solve this, we get x greater than 2. So if we plot this inequality and this inequality, that is the solution region, then x greater than 0 is this portion, and x greater than 2 is this portion. Clear? Now case 2 is when both the products are less than 0. Clear? Both the products are less than 0. So here we have x less than 2. If we solve this one, we take minus 2 to this side. Now if we plot this region and this region, then x less than 0 is this region and x less than 2 is this region. Clear? So viewers, from these two cases, we find that the common region is this up to 2 to infinity, and here we have minus infinity to 0. Clear? So therefore fx is said to be a decreasing function if x belongs to minus infinity to 0, minus infinity to 0, because this is the common region, and then we have this region, so we have union and 2 to infinity. Clear? So this is the interval in which this function is decreasing. Clear? Now let us combine these two results, and we can say that if this is the real number line and here we have 0 and 2, then from this region, that is minus infinity to 0, we have the function as decreasing, and similarly in the interval 2 to infinity we have the function decreasing. So we are denoting it by negative sign. Why? Because for decreasing function the derivative is less than 0. Okay, so in these two intervals the derivative is less than 0, so we are denoting it by negative sign. Similarly, we saw that this function is decreasing in this increasing in this interval 0 to 2. So here we have this interval 0 to 2, and here we have positive sign. So it means this function is increasing because f dash x is greater than 0. So when the derivative is less than 0, then the function is said to be decreasing, and when the derivative is greater than 0, then the function is said to be increasing. So in this number line, this function is increasing from 0 to 2, and it is decreasing from minus infinity to 0 and union 2 to infinity. Clear? Okay, now viewers, here I am going to tell you one more thing. Clear? So we are analyzing this question, and we have fx, the derivative of f as x e raised to minus x and 2 minus x. Clear? We calculated So we calculated the derivative of this function as x times e raised to minus x and 2 minus x. Now for the turning points, or stationary points or critical points, we have the derivative equal to 0. So here we have x e raised to minus x, 2 minus x is equal to 0. So this can be written as 2 times x times 2 minus x equal to 0, because e raised to minus x is not equal to 0. So if we solve this equation, we get x equal to 0 and x is equal to 2. So here's this 0, x equal to 0 and x is equal to 2 are the critical points or the stationary points here. Clear? So this is why we have located 0 and 2 on this real number line. Clear? So viewers, let us take one more problem. Now viewers, we have this problem. Prove that the function fx is equal to log of sin x is increasing on 0, pi by 2 interval and decreasing on pi by 2 to pi. Clear? Now we have to solve this problem. Now here we have fx is equal to log of sin x. Now let us find the derivative of f. Clear? So f dash x is equal to the derivative of log sin x is 1 over sin x, and the derivative of sin x is cos x. Clear? So here we have cos x over sin x, that is cot x. Clear? Now this function fx, we have to prove that it is increasing on 0 to pi by 2. Clear? Now here's now in the interval 0 to pi by 2, we see that cos x and sin x both are positive. Viewers, in the interval 0 to pi by 2, it is very clear from the graph of the functions as well that in the interval 0 to pi by 2, cos x and sin x both are positive. So here this is positive and this is also positive. So therefore this derivative is positive. Clear? So hence we can say that the derivative of f is greater than 0, or it is positive for all x belonging to this interval. Therefore this function fx equal to log of sin x is increasing, because by the first derivative test we have a function to be an increasing one if its derivative is greater than 0 for all x belonging to the given interval. Clear? Now in the interval we have to prove that this function is decreasing on pi by 2 to pi. So in the interval pi by 2 to pi, we see that we see that we are in second quadrant. We are in second quadrant because see, this is 0, this is pi by 2, this is pi, and this is 3 pi by 2, and again this is 2 pi. So when we are in the interval 0 to pi by 2, that is we are in first quadrant, 0 to pi by 2. So sin x and cos x both are positive in first quadrant. Therefore, this derivative is positive. Hence, this function is increasing. Now, in the interval pi by 2 to pi, that is we are in second quadrant. And in second quadrant, cos is negative, but sin is positive. Clear? So, therefore, now f dash x is equal to this cos x is negative in second quadrant and sin x is positive. So this quotient is negative. Clear? So therefore this function fx equal to log of sin x is decreasing in pi by 2 to pi. Clear? So viewers, this is how we solve this problem, and here I would like to mention one thing, that in the four quadrants here all are positive, that is all the 6 trigonometric functions are positive in the first quadrant. In the second quadrant only cos is positive, and the other rest of the 5 trigonometric function, sorry, here I would like to correct it. I'm sorry, here only sin is positive and other 5 trigonometric functions are negative, and here only tan is positive. Clear? And here we have only cos is positive. Clear? So we remember it as A S T C. Clear? So this is in the first quadrant we have all 6 trigonometric functions positive. In the second quadrant only sin is positive. In the third quadrant only tan is positive, and in the fourth quadrant only cosine function is positive. Clear? Now viewers, will solve some more problems which are based on polynomial functions. So here we have a quadratic polynomial, and find the intervals in which the function given by fx is equal to x square minus 4x plus 6 is increasing or decreasing. So here we have to find the interval. To find the interval means this is the real number line, and we have to find the intervals in which this function is increasing and decreasing. Clear? So let us find the derivative of f. So the derivative of f is 2x minus 4. Clear? Now for turning points or the critical points, we have the derivative is equal to 0. So 2x minus 4 is equal to 0. So we have 2x equal to 4. So x is 2. Clear? The value of x is equal to 2. So what does it mean? It means that initially we have the polynomial of degree 2. But when we differentiate this function, we get this derivative as a polynomial of degree 1. Clear? So we have one root. This is x equal to 2. So it means we have to locate this point x equal to 2 on the number line. Okay, so this is the point 2. Clear? Now viewers, for this function to be increasing, for fx to be increasing, we must have the derivative of f greater than 0. Okay, so it means this expression, that is 2x minus 4, must be greater than 0. Now this can be written as x minus 2 greater than 0 or x greater than 2. Clear? So x is greater than 2 means this is the solution region. Clear? Now for fx to be decreasing function, the derivative must be less than 0. So it means 2x minus 4 must be less than 0 or x minus 2 must be less than 0. This implies that x is less than 2. So this is the reason which represents x less than 2. So here we write positive sign and here we write the negative sign. So positive sign implies that this is for positive sign, because in this interval, for increasing, the interval is x must belong to 2 to infinity, and this function fx is decreasing in this interval, that is minus infinity to 2. Clear? So this point x is equal to 2 divides the number line into two intervals. One interval is minus infinity to 2, in which the function is decreasing, and in the interval 2 to infinity the function is increasing. Clear? So viewers, here we have a quadratic polynomial and the derivative is a linear polynomial. Now let us see a cubic polynomial, and when we differentiate the cubic polynomial we get a quadratic polynomial. Clear? Now viewers, here we have a cubic polynomial. This is a cubic polynomial. Now here we have to find the intervals in which this cubic polynomial is increasing and decreasing. Clear? So let us first find the derivative of f. The cubic polynomial has degree equal to 3. So the degree of the derivative is 2. Clear? Now find the derivative of this function fx. So we have this is 12x square and minus 12x minus 72. Clear? The derivative of x cube is 3x square, the derivative of x square is 2x, and the derivative of x is 1. Clear? Now let us take here 12 as common factor. So we have x square minus x minus 6. Now here we have a quadratic polynomial. Now let us factorize it. So we have x square minus 3x plus 2x, this is minus 6, so we have 12, and then we have x minus 3, then we have 2 here, x minus 3, and then we have 12 times x minus 3 and x plus 2. Okay, so here we have obtained the derivative of f as a product of two linear factors. Okay, we can write this expression in a general form. Suppose this is k and this is x minus alpha and this is x minus beta. Clear? Now let us draw the number line here. Clear? Now here's for the critical points or the stationary points, the derivative of f should be equated to 0. Okay, so f prime of x is equal to 0. Now this implies that 12 times of x minus 3 x plus 2 is equal to 0. So we have x is 3 and minus 2. So we have obtained two roots of this polynomial. Clear? So x equal to 3 and x equal to minus 2. So we locate these 2 points on this number line. So this is minus 2 and this is 3. Clear? So here we have a cubic polynomial of degree 3, and then we differentiated the function and we have a polynomial of degree 1 less than the degree of this function. So 2, this is 3 minus 1. Clear? And we have two roots. Clear? Say this is alpha and this is beta. Clear? So this is alpha here and here we have beta, and k is our the value of k is 12. Now fx is said to be increasing function if the derivative is greater than 0, and fx is said to be decreasing function if f dash x is less than 0. Okay. Now here's let us come to this number line. So here we have two roots, 3 and minus 2. So this number line is divided into 3 intervals. The interval is minus infinity to minus 2. Then we have one interval as minus 2 to 3, and then we have 3 to infinity. Clear? Now we have to calculate, or we have to determine in what interval this function is increasing or decreasing. Clear? So we have calculated the value of x equal to 3 and minus 2. Now let us come to this point. Suppose we have a polynomial fx, and here I am telling you the trick how to find the intervals. So if we have a function or polynomial fx, then we differentiate it, and if we are able to express the polynomial in this form, this polynomial, that is the derivative, if the derivative is expressed in this form, k times x minus alpha x minus beta, then we will write from the right side, and this interval is positive. We write the plus sign here. If we express this derivative in this form, which is given by 12 times x minus 3 x plus 2. Clear? So if we are able to express a derivative in this form, then we start from the positive sign from the right side of this root alpha. Clear? So we have plus here, then alternatively we can write minus, and then we have plus. So plus, minus, plus. So this is the rule. Clear? So here this interval is from 3 to infinity. We have the derivative as positive. Again, from minus infinity to minus 2, the derivative is positive. So therefore fx is increasing if f dash x is greater than 0 and x belongs to minus infinity to minus 2 union 3 to infinity. Okay? And in the interval minus 2 to 3, we have this function in decreasing manner. Clear? So fx is decreasing if f dash x is less than 0 and x belongs to minus 2 to 3. Clear? So here's this is how we locate the intervals in which the function is increasing or decreasing. Clear? So here we have to keep one thing in mind, that we have this function fx, then we differentiate it, and if we are able to express this derivative in this form, that is k times x minus alpha x minus beta, and this k is here, this k is positive, then we locate the roots in this manner here on the number line, and then we start from the right by writing a plus sign in the first interval, that is from alpha to infinity. Then we alternatively we write minus, and then we have plus. Clear? So from minus infinity to minus 2 and union 3 to infinity, this function is increasing, and from minus 2 to 3 it is decreasing. So if we want to write it in general form, then we should write x belongs to minus infinity to beta union alpha to infinity. So this is the interval in which this function fx is increasing, and fx is decreasing when x belongs to beta to alpha. Clear? So this is how we solve this problem. Clear? Now viewers, here I would like to mention one thing, and that is suppose we have a polynomial, say fx is a polynomial, and we find the derivative of this polynomial, and if we are able to express this polynomial in this form, k times x minus alpha x minus beta x minus gamma, say. Clear? So if this is a polynomial of say degree 4, then we have the derivative as a polynomial of degree 3. Clear? And if we are able to express the derivative in this form, then the roots are alpha, beta and gamma, and here we have the constant as k. So then we plot these points as alpha, beta and gamma, and here we'll keep in mind that which root is to be written first. Clear? Say if alpha is -2 and beta is say 1 and gamma is 2, then obviously this will be -2 and this will be 1 and this will be 2. Clear? Then we have then we will divide this number line, real number line, into 4 parts. So this is the first one, this is second, this is third and this is fourth. And then we'll start from the right by writing plus sign. Clear? Then we have here plus, then we have minus alternatively, then we have plus, and then we have minus. So this function fx will be increasing, and if the derivative of f is greater than 0, and from this number line the interval will be alpha to beta, because here we have positive sign, so the derivative has to be positive. So here we have alpha comma beta union gamma to alpha, gamma to infinity. So this is the interval in which this function fx is increasing. Clear? Now this function fx is said to be decreasing if the derivative is less than 0. And on the number line we see that in the interval -infinity to alpha, here -infinity to alpha union, then we have beta to gamma, so this is the interval in which this function fx is decreasing. Clear? So this is how we find the intervals in case of polynomial functions. Now let me tell you here one more thing. Clear? So if we have this derivative in this form, that is k times x minus alpha, x minus beta and x minus gamma, then this will be the scheme. Clear? Then by this scheme we'll write the intervals for function to be increasing and decreasing. But if we have this derivative f prime of x equal to, say, if we have minus k, and then we have x minus alpha, x minus beta and x minus gamma. So if this derivative is expressed like this, that is, here we have the positive sign and here we have the negative sign, in that case what we will do, we will just reverse what we have done in the first case. Clear? So now this becomes negative. Again we'll start from the right, and but this time this positive will become negative. Clear? This will become negative, or we'll start with negative sign if here we have the negative sign. Clear? So negative, then we have positive, then we have negative, then we have positive. Clear? And in that case the function fx, if this is the case, the function fx will be increasing if f prime of x is greater than 0, and the interval will be, in that case the interval will be for increasing interval will be minus infinity to alpha union beta to gamma. Clear? So the scheme will be reversed. Similarly, the function will be decreasing if x belongs to alpha to beta union gamma to infinity. Clear? So here's we have to keep this trick or method in our mind, that if fx is a polynomial of say degree 4 or say n, then its derivative will be a polynomial of degree 1 less than the polynomial itself, that is 3, or in case of general polynomial, then we have n minus 1 degree for f dash x. Clear? And if f dash x is k times this, we can express it like this. Then we have this scheme, and we'll start from positive sign and alternatively negative, positive, negative. Clear? And if the derivative is expressed like this, that is, here if we have a negative sign and the rest is same as the previous one, then the scheme will be reversed, and then we will have to start from negative sign from the right side. Clear? So here we have minus, then alternatively plus, minus, plus, and the interval will be reversed here. Clear? So let us do one more problem. Now viewers, what I have discussed just now, I am going to take up one problem related to that, and here we have to find the intervals in which the function given by fx equal to minus 2x cube minus 9x square minus 12x plus 1 is increasing or decreasing. So here we have to find the intervals. So let us find here this is a cubic polynomial. Okay, so its degree is 3. Clear? Now here let us draw the number line, because we will require this number line in our later discussion. And then this is the derivative. Find the derivative of f. So this is minus 4x, sorry, it is minus 6x square minus 18x minus 12. Okay. Okay, now take minus sign outside, then we have x square plus 3 and plus this is x plus 2. Clear? So here's we have minus 6 here, and if we factorize this term by splitting middle term, then we have x plus 2 and x plus 1. So viewers, I have just told you that this is of the form minus k x plus 2 x plus 1. Clear? So this is we can write it like this, and this is of the form minus k x minus alpha x minus beta. Okay, so if we put the derivative of f equal to 0, we have minus 6 x plus 2 x plus 1 equal to 0. So here we have x equal to minus 1 and minus 2. So these two are the stationary points, or we can say these are the critical points. Now let us plot these 2 points or locate these 2 points on the number line. So this is the real number line. So here we have minus 2 and here we have minus 1. Okay. So viewers, as we have discussed just now, that here we have the negative sign. Clear? Here we have the negative sign. So we'll start from the right with negative sign. So this is negative, this is positive alternatively, and here we have negative. So therefore we can say that this function fx is increasing if the derivative is greater than 0 for all x belonging to -2 to -1, because this is the positive sign, and positive sign means for increasing function the derivative must be positive. So the interval in which this function fx is increasing is the open interval -2 to -1, and fx is said to be decreasing function if f prime of x is less than 0, if the derivative is less than 0, and the interval is here -infinity to -2, and union, because here we have negative and here we have negative, and it is from -1 to infinity. Okay, so here's what we have discussed here. We have a polynomial fx which is a cubic polynomial, degree is 3. We differentiated this function fx and we get -6 times x plus 2x plus 1, x equal to -1 and -2 are the two critical points. Since here we have the negative sign, so we start from negative sign, then positive, and then negative, and so on. Okay, in an alternative way. If we have a positive sign, or had we solved it, or had we if we had a problem in which we have a positive sign here, then we should have written here positive. Clear? So this is how we solve this problem. Clear? Now viewers, let us have this problem here. Find the intervals in which the function given by fx equal to 6 minus 9x minus x square. So this is a quadratic polynomial and the degree is 2, and we have to find the intervals in which this function is increasing or decreasing. Clear? So let us find the derivative here. So we have minus the derivative of 6 is 0 here, and this is -9, and we have minus 2x. Clear? Now for the critical points we have f dash x equal to 0, and this implies -9 minus 2x is equal to 0, so this is -9 equal to 2x, x is -9 by 2. Clear? Which is equal to -4.5. Clear? Now this is the critical point here. So let us draw the real number line here, and the critical point is -9 by 2. So here we have two intervals. Clear? Now we can write here, this expression can be written like this. See, f dash x can be written as minus of 2x plus 9. Clear? Or we can take 2 common here, and we have x plus 9 by 2. So as we have just discussed, this is of the form k minus k times x plus or x minus beta. Clear? So when we have here the negative sign, then we start from negative. Clear? If we have positive sign here, then we should have started with positive sign. So here we have negative sign, so we start from negative sign. So negative, and then alternatively we have positive. So therefore uh, fx is increasing function if the derivative of f is greater than 0. It means we have this interval, that is x belongs to minus infinity to minus 9 by 2. So this is the interval in which the function is increasing. Similarly, fx is decreasing function if the derivative is less than 0, and the negative sign shows that in this interval the derivative is negative. So x belongs to minus 9 by 2 to plus infinity. Clear? So this is the interval for increasing function, this is for decreasing function. Clear? Now viewers, let us have this problem. Here we have to find again the intervals in which the function given by fx is equal to 2x square minus 3x. This is also a quadratic polynomial, and here also we have to find the intervals in which the function is increasing or decreasing. So let us first find the derivative. So the derivative is 4x minus 3, and for critical points we have the derivative is equal to 0, so we have 4x minus 3 is equal to 0, so x is 3 over 4. So this is the stationary point. Now we have this real number line, and here we have the critical point, this is 3 by 4. Now we have two intervals here. First is from minus infinity to 3 by 4, and the second one is 3 by 4 to infinity. So we can write this expression as 4 times of x minus 3 by 4. So this can be expressed as I have just told you, k times of x minus alpha. Clear? So here we have a positive sign. Clear? Here we have positive sign. So therefore we start from the positive sign here, and then we have negative sign. Okay? So therefore fx is increasing if the derivative is greater than 0, and the derivative will be greater than 0 if x belongs to the interval 3 by 4 to infinity, because here we have positive sign. And similarly fx is decreasing if f prime of x, or the derivative of f, is less than 0, or x belongs to, here we have the negative sign. Clear? So we have minus infinity to 3 by 4. So this is the interval in which this function fx is increasing, and this is the interval in which this function is decreasing. Clear? So viewers, in today's lecture we have discussed some important problems related to increasing and decreasing functions, and we have determined the various intervals in case of polynomial functions. And in our next lecture we will solve some more problems on increasing and decreasing functions involving trigonometric functions. So till then, keep watching my videos, and goodbye.